Have you ever wondered how artificial intelligence could revolutionize healthcare? In today's video, we'll explore Google's groundbreaking research paper, The Capabilities of Gemini Models in Medicine. Discover how Google's Gemini model is not only fine-tuned for medical applications, but also outperforms previous AI systems, promising a new era in medical diagnostics and patient care. Earlier this year, Google also released something similar called AMIE, or Articulate Medical Intelligence Explorer. AMIE is an advanced AI system designed to handle medical diagnostics and engage in meaningful conversations within a medical context. It aims to improve interactions between physicians and patients, as well as enhance the quality and accessibility of consultations. AMIE uses a simulated learning environment to improve its skills. It engages in diagnostic dialogues with AI patient simulators, allowing it to practice and refine its conversational and diagnostic abilities continuously. It was trained on a diverse set of medical data, including real-world clinical conversations and medical reasoning scenarios. One of the key highlights of AMIE is its performance compared to clinicians. When used by itself, AMIE performed better than unassisted clinicians. Even when clinicians were assisted by internet searches, AMIE showed a significant improvement. The biggest difference was when clinicians were assisted by AMIE, showing that the AI system greatly enhanced their performance. Although this isn't about Med-Gemini directly, it shows that Google is making significant strides in medical research. These AI systems, like AMIE, are proving to be very effective, even surpassing clinicians in certain tasks. This demonstrates Google's commitment to advancing medical technology and improving healthcare through AI. Now let's dive into Med-Gemini. We start with the basic Gemini system, which is a family of powerful AI systems. These systems are multimodal, meaning they can process different types of information simultaneously. Gemini's core capabilities include advanced reasoning, understanding multiple types of data, and processing long contexts. To develop Med-Gemini, the team focused on medical specialization. They used self-training with web search integration and enhanced the system's ability to understand different types of data. They fine-tuned the AI with customized encoders and used a technique called chain of reasoning prompting for better long context processing. Combining all these improvements, they created Med-Gemini, a version of Gemini specialized for medical applications. This is fascinating because it shows how AI can revolutionize the medical industry with its advanced capabilities and impressive benchmarks. Before Med-Gemini, the medical AI field had seen significant advancements. From September 2021 to September 2023, there was a noticeable improvement in AI systems' accuracy and capabilities. We saw the evolution from models like GPT 3.5 to Google's Med-PaLM, then GPT-4 and Med-PaLM 2. The previous state-of-the-art model before Med-Gemini was GPT-4, particularly its fine-tuned version. This model scored 19.2% on the Med-QA benchmark, which measures AI systems' performance in answering medical questions. GPT-4 with the Med-PaLM prompt was a high benchmark, but Google has now surpassed it with Med-Gemini. The impressive part about Med-Gemini is that it doesn't rely on complex techniques like ensemble with choice shuffle. For example, in multiple choice questions, people might subconsciously pick the first answer as correct. To counter this bias, answers are shuffled, and the most commonly picked answer is chosen. While this technique improves performance, Med-Gemini excels without such complex methods, showing just how advanced and effective it is. Interestingly, Google's Med-Gemini has set a new benchmark on the Med-QA, scoring 91.1%. This is a significant improvement. Some people might think that we've reached the limit of what large language models can do on these benchmarks, but many also disagree. It's important to note that 7.4% of the questions in the dataset have quality issues or ambiguous answers. This would be a consistent problem in AI benchmarking. Many questions are unclear or poorly worded, making it impossible for AI systems to answer them correctly. Even with these issues, Med-Gemini still performs exceptionally well. When comparing Med-Gemini to previous state-of-the-art models like GPT-4 with the Med-PaLM prompt, Med-Gemini outperforms them in nearly every category. The blue bars on the graph represent Gemini, and we can see it surpasses the previous best in almost all areas. There are a few categories where it's on par, but overall, the improvement is clear. Med-Gemini excels in advanced text-based reasoning tasks. It surpasses GPT-4 in many categories, especially in handling long context reasoning. This is crucial for the medical field because more data leads to a better understanding of a patient's condition. The human body is complex, and having the ability to process more information helps in making accurate diagnosis. Long context reasoning is essential for the future. It allows the system to consider more data points, leading to better conclusions. This feature is vital in the medical industry, where understanding the intricate connections within the body is key. Overall, Med-Gemini not only outperforms previous models, but also represents a significant step forward in medical AI. It shows how AI can enhance our ability to diagnose and understand complex medical conditions, paving the way for more advanced and accurate healthcare solutions. One cool thing about Med-Gemini is its advanced reasoning capabilities, which are a bit different from other models. Med-Gemini uses two main methods: self-training and search. These enhance its ability to handle complex medical data and queries. First, let's talk about self-training. Med-Gemini uses its own outputs to create new training examples. This helps improve the model, especially when the initial training data is limited or not diverse enough. Med-Gemini processes medical data or questions and creates responses based on what it knows. These responses, along with their context, become new training examples. These examples are fed back into the training cycle. This iterative process helps Med-Gemini refine its reasoning and decision-making abilities, especially for complex medical scenarios. Med-Gemini also uses simulations. These scenarios involve interpreting complex medical data from text, images, or long medical records. Feedback from these simulations helps the model improve its accuracy and reliability. Now let's discuss the search feature. When Med-Gemini encounters a tough question, has low confidence, or lacks enough internal data, it can perform a web search to gather more information. When the model is unsure about its predictions, it proactively searches for more information before giving a final response. This improves the accuracy and reliability of its answers. By searching and integrating information from external sources, Med-Gemini can continuously update its knowledge without needing frequent retraining. This is crucial in the medical field, where new research and practices can quickly change. Combining these two approaches, Med-Gemini can adapt to new or rare medical scenarios and access the latest medical information. Its data isn't just based on initial training, but also the newest studies, clinical trials, and guidelines. Through continuous learning and adaptation, Med-Gemini becomes more proficient at handling diverse and complex medical queries, making it a valuable tool for medical professionals seeking AI support. Now let's talk about the video benchmarks. Google's Gemini 1.5 Pro can analyze up to an hour of video, which is pretty impressive. It can review these videos and understand medical scenes. For example, it compares the performance of Med-Gemini with previous models like Med-PaLM, GPT-4 Vision, and more. We're curious to see how GPT-4 will perform in this area once it's released its video capabilities. It'll be interesting to see how it stacks up against Med-Gemini. From different experiments with the system, we can see that Med-Gemini, especially when combined with search capabilities, performs much better than clinicians alone. This indicates how AI can help bridge knowledge gaps for doctors, providing significant support in medical diagnosis. However, it's important to remember that while AI is a powerful tool, it shouldn't completely replace human judgment. AI systems can sometimes miss subtle details that a human might catch. For instance, if a patient says they have a runny nose to an AI, that's all the AI knows. But a human doctor can see how the patient looks, moves, and acts, considering more factors like age, fatigue, and family history. As mentioned earlier, while Med-Gemini performs well, there are some issues with the benchmarks used. For example, when reviewing the MedQA benchmarks, it was found that some questions had missing information, like figures or lab results. Additionally, some questions had incorrect answers or were unclear. To address these issues, each question was reviewed by at least 3 U.S. doctors. They re-evaluated the questions, corrected answers if needed, and noted any missing or unclear details. They used a method called bootstrapping, where a committee of 3 reviewers decided if a question should be excluded due to flaws. The findings showed that 3.8% of questions were missing information, 2.9% had incorrect answers, and 0.7% were unclear. Most reviewers agreed on these assessments, which led to a strong consensus. By removing flawed questions, the accuracy of Med-Gemini's test improved from 91.1% to 91.8%. When using more relaxed criteria, the accuracy further increased to 92.9%. In simple terms, by cleaning up the test and fixing flawed questions, they made it a better tool for accurately assessing the AI's ability to handle medical queries. Lastly, let's clarify the differences between AMIE and Med-Gemini. AMIE is designed for improving diagnostic dialogues and reasoning during medical consultations. It focuses on interactive conversation, history taking, diagnostic accuracy, and patient communication. On the other hand, Med-Gemini is a more generalized AI model specializing in processing complex medical data such as text and long records. It integrates broad medical knowledge to assist in diagnostics and treatment planning beyond conversational capabilities. In essence, AMIE aims to enhance medical consultations through better communication and diagnostic support, focusing on the human aspects of medical practice. Meanwhile, Med-Gemini aims to provide comprehensive analysis of patient information, aiding medical professionals in making information decisions based on vast data. In the future, these AI systems could break language barriers, ensuring more people receive accurate medical care, regardless of language differences. This advancement could significantly improve healthcare accessibility and quality worldwide.